about how to find the area and perimeter of a regular polygon. First, what's a regular polygon? Regular polygon is one that is equiangular and equilateral. It doesn't matter how many sides it has, but all the sides need to be exactly congruent, so the exact same length, and all the internal angles need to be congruent. So here's an example of a regular polygon, or my best attempt at it. This is an octagon. It's got 8 sides. If you count them up, you'll see 8. And I'm claiming that it's regular. It's designed to be as such. So all 8 sides have the exact same length. That's given information for you. So if you want to find the perimeter, well, that's just the length around the outside. Like say this is a field and you're trying to make a fence or something, you would need this much fencing, right? Each side would take 12 units. So if we take 12 and we multiply it by 8, 12 times 8, we'll see that that measure is 96. So the perimeter of this thing is 96 units. Okay, that's easy peasy. Now we're going to dive into the area. This is a little bit more complicated, but we're going to break it up into shapes we're familiar with, just like we've done with other composite figures. And we're going to create a general rule that will work with all regular polygons, not just octagons. So the first thing I want to point out is if we have a center of this thing, just like a center of the circle, we can connect that center to each vertex. I'll show a couple of them here. And if we do that, second one here, you'll notice that a triangle is created. And it's not just any triangle, it's an isosceles triangle. Both these lines must be congruent to one another, so these angles are going to be congruent. And, well, because each of these sides have the length of 12 in this case, if we were to go all the way around, what we would have is we would have 8 congruent triangles, 8 congruent isosceles triangles. That's pretty powerful, because if we can find the area of just one of these things, then we can multiply that number by 8, and we'll have the area of the entire figure. Okay, I'm going to pause and do a little work, and we'll come back together. All right, I went ahead and connected the center to each vertex, creating 8 congruent triangles. And so they're congruent, so we can find the area of one, we just multiply it by 8, and then we have the area of the entire figure. That's pretty cool. I've also included this line here, and it's in green. I'm not sure if you can catch that in the video. But this is the height of one of the triangles. That height would be the same if I were to connect it in any of these other triangles. I just chose this one on the bottom arbitrarily. So this is the one we're going to be working with specifically. We're going to find the area of this triangle, and then we're going to multiply it by 8. So recall, so this is what I just said, area of the triangle and then multiply it by 8. Recall that the area of any triangle is 1/2 times base times height, and then this 8 is the same as this 8, and the reason why it's 8 is because there are 8 sides or 8 triangles in this particular figure. So let's fill in what we know here and then try to figure out what we don't know, and then we'll accomplish that too. So 1/2 times the base, well, the base of this triangle is the side of the regular octagon. And we know that because it's regular, all the sides are the same, so the base is exactly 12 units. Times the height. Yikes. I mean, that's this green line here. We don't have that information yet, so we're going to put that on hold. I'll call it H, and then we'll have this 8. Okay, so now really our only missing piece is to find that height. If we have that height, we throw it in our calculator, and we're done. This is good news. Some work to do though. So to find this height, what I would challenge us to do, or encourage you to do, I think the easiest way to approach this, believe it or not, is we're going to dust off some of our trig skills. So also we're going to take into account, remember, all 8 of these triangles are congruent, meaning that all 8 of these angles are congruent. They must be, by definition. Okay, now if those are all the same, well, they all go in a complete circle, so they have to add up to 360. The measure of a circle is 360 degrees. So we're going to take our 360, divide it by 8, and that will give us the measure of each of these vertex angles. So calculator, 360 divided by 8, and my calculator tells me, oh, nice, that's almost like cheating. It's 45 degrees. So each of these is 45 degrees. We're focused on this bottom one, so I'll put that in, 45 degrees. That's the entire vertex angle. Now with that, we we could find the base angles. Turns out we don't care about those, but we could. What I'm interested in doing is I want to isolate one of these right triangles that we've created when we dropped in the height. It really doesn't matter which. I'll choose the one on the right arbitrarily. You can do the one on the left if you want. They're the same thing. It just chops it in half. And so with that, that means that this angle here is 22.5 degrees. I just took the 45 and I chopped it in half. Okay, this is getting kind of loud, kind of messy. I'm going to recreate that triangle. So it's this triangle here that I'm recreating right now. We want this H. This is a 22.5 degree angle. And this length right here. Well, it's half of the entire side. The entire side has length 12, so the base of this thing is 6. Now you might see where we're going with this trig stuff, right? So we have an angle measure, we have a side, and we have an unknown side. So I'm going to look at it from the perspective, I'll just call this A, B, and C arbitrarily here. From the perspective of angle A, I have the opposite side, I want the adjacent side. So thinking of SOHCAHTOA, I'm going to use the tangent function. So this should go pretty quick. It's the tangent of 22.5, that's this angle measure, equals the opposite leg over the adjacent leg, which happens to be an H. That's annoying. It's not the hypotenuse. It's the height of the triangle. So multiply both sides by H. You'll see that H times the tangent of 22.5 equals 6. Divide both sides by the tangent of 22.5. We'll just stick it up here. H equals 6 over the tangent of 22.5. And now we've isolated the H. We've done all we can do by hand. Let's dive into our calculator. 6 divided by this business. 6 divided by the tangent of 22.5. And the calculator says, mine says 14.48. 14.49. So 485. So H is 14.48. Oh, 49. 485. Okay, cool. Now we have our H. Let's plug it in where we have that missing H value. So we have 1/2 times the base of the triangle times the height of the triangle times the number of triangles that this thing is composed of. Back to the calculator. 1/2 times 12 times 14.49 times 8. So 0.5 times 12 times 14.49 times 8 equals, I got, in this case, did I get it all in there? I did. I got 695.52 units squared. There it is. This is the area of our regular octagon. Okay, cool. All right, I'm going to erase this real quick, so feel free to pause, do what you need to do, because I need to show you something in general. What if we don't have an octagon? What if this was a 5-sided figure? What if this was a 6-sided figure? Well, then we're not multiplying it by 8. We're multiplying it by 5 or by 6. What if it's a 10-sided figure? What if it's a 50-sided figure? What if it's a 1,000-sided figure? All that's fine. It's pretty theoretical, and it's a little, it might take some time to calculate, but you would just replace this number by however many number of sides you have. So, in general, to find the area of any regular polygon, you're going to use the following formula. Area equals 1/2 times the base of your triangle. So I'm going to call that S for side length. Let's define this as we go. S equals side length. So it's 1/2 times base times height. Here's a new word for you. Check the notes for spelling and all that type of stuff. It's the same word in the notes. This word it's the height of the triangle, what we have marked here in green. This is the stuff that we found using the trigonometry stuff. You won't always have to use trig, by the way. In this case, we did. This is like the most challenging version of this problem you'll ever encounter. That's why I showed it here. A lot of times you're just given this length. But this length has a special name. It's called the opossum. Apothem. So A is opossum. And again, that's just a fancy word for this green length here. It's the height of one of the triangles. Every one of these triangles has what we call an opossum. All of them are congruent to one another. So it's just the height of one of the triangles. So 1/2 times the base of the triangle times the height of the triangle, which has a fancy name called the opossum. And then we take that, this will give us the height, the area of our triangle, and then we multiply that by the number of sides in the entire figure. So n represents the number of sides. This is your big formula, and this is what everything represents. So again, to recap from what we've done in our problem, we did the area of the triangle times 8. So 1/2 base times height. The base of this triangle was 12. We plugged that in here. The opossum, that was, shoot, I forget what it was. Whatever we found using the trig, we plugged it in here. And then the number of sides was 8. This will work for any polygon ever, any regular polygon. Must be a regular polygon, but it'll always work. Okay, this is how to find the perimeter and the area of a regular polygon. Let's dive into some practice problems. You got this.